Hello, welcome everyone. Welcome back to our generator protection series. In this video, we will discuss the rotor earth fault protection or the field ground protection identified as 64R or 64F in the ANSI code. This function detects the insulation failure in the excitation circuit of synchronous machines. Since the rotor is normally ungrounded, a single fault may go unnoticed, but a second fault can cause a short circuit leading to a severe vibration and mechanical damage. We will briefly look at how this protection works, including the traditional DC overvoltage relay method and how modern systems handle these faults more effectively. So let's get started. So as an introduction, in this slide, we are introducing here the rotor earth fault protection, also known as the field ground protection, which is identified by the ANSI code 64R or 64F. And as explained, this protection function is crucial for asynchronous machines as it monitors the excitation circuit for insulation failure. The rotor winding circuit normally is ungrounded, which means that if a single earth fault occurs, there is no any current flow and the fault can remain undetected. While one fault alone doesn't immediately cause damage, it creates a dangerous situation because if a second fault develops elsewhere in the circuit, it results in a short circuit through the rotor winding. This causes unbalanced magnetic forces that rotates with the rotor and leading to a severe vibrations, mechanical stresses, and potential damage to the rotor and bearings. Traditionally, detection was done using the simple DC overvoltage relay connected between the negative side of the field and ground. So energized by a small DC source, and the relay included a 1 to 3 second delay time to avoid any misoperation or trips from the transient voltage, especially important in the thyristor-based excitation system where rapid change in the voltage are common. Overall, the 64R and 64F protection is a preventive safeguard, ensuring that insulation weakness in the rotor field circuit are detected early before they escalate into costly mechanical failures. So here is the test module setting. For this example, the rotor earth fault protection is implemented using the protection function sensitive earth fault with address 0051 in the Siemens 7UM protection relay. So we have both stage. The first stage, the setting is 10 milliamp with a time delay equal to 10 seconds for warning stage, and second stage for tripping with a pickup value equal to 23 milliamp and the trip time delay equal to 1 second. And here is the local hardware configuration. So we need a 3 voltage output must be mapped as a phase neutral voltage, as you can see from the wiring diagram here, and we need only one current equipped from the current system A, which is called L1 or which is used as IE, and the start and trip command from the REF warning or REF trip must be mapped to the binary input of the CMC. So here is the test module setting. As you can see, we can test the pickup value of the first stage of the rotor earth fault protection using the ramping module. So during all the ramps, the nominal voltage should be implemented and should be applied here during the entire test sequence. So we have 3 ramp. As you can see, here is the ramp 1 for stabilizing the protection relay in advance before starting the test with a current equal to 0 amp. And as you can see, here is a signal which is IE to be ramped up or ramp it down in terms of the magnitude. So ramp 2 also we will ramp up the current from 8 to 12 milliamp because we are expecting 10 milliamp, and ramp 3 also we will ramp down the current from 12 milliamp to 8 milliamp. And here is the trigger condition for ramp 2. So the start contact or the warning stage contact will change from 0 to 1, and in ramp 3 it will change from 1 to 0 to indicate the drop of value. And also in order to assess the pickup and the drop of values, a corresponding assessment has to be done and has to be defined in the ramp assessment view. Also, you can get the reset ratio, which is called drop off divided by the pickup value, and it should exceed 90% based on the relay technical specification. And here you can see here from the analog output detail view that the nominal voltage has to be applied during the entire test sequence. Now we will talk about the pickup for the second stage. As you can see, we will use the Test Universe pulse ramping module here to avoid any manipulating of the first stage and to avoid any interference with the first stage if we are using the same contact for picked up. So we will need here the nominal voltage also to be applied during the entire test sequence, and we will use the pulse ramping for the second stage. So here is the start value of the pulse ramping. And here is the stop value of the pulse ramping, and here is the delta, which is 200 microampere. In our case, you have to define the pre-fault time. the reset time to allow the relay to go to its reset state, and the fault time, which should be higher than the expected trip time in this case, because we are using the trip contact in this case as the trigger condition, as you can see from the assessment view here. So the trip from 0 to 1 is our trigger condition, and we are expecting 23 milliamp, which is the pickup value of the second stage. So the fault time should be more than 1 second. So now we are considering 1.5 second, which is more than enough to detect the pickup value of the second stage. Here is the third test, which is the trip times for both stages. So trip time for both warning and trip stages can be tested using the Test Universe state sequencer module, and also consider the nominal voltage has to be applied during the entire test sequence, as you can see from here, 60.62 for all test sequence. And here is state number 1 to be healthy, to simulate the healthy state or the pre-fault state. State number 2, now we are injecting value of more than the stage 1 backup current, which is 10 milliamp. So we are injecting 15 milliamp, and the trip time now is expected to be 10 seconds. So here is the time to be more than this expected trip time. And the trigger condition here, as you can see from the trigger logic, to be used with the warning stage, to changing from 0 to 1 to detect the warning or the delay time of the stage 1. Then in state number 3, we are simulating again the healthy and the pre-fault before injecting the state number 4 to detect the trip time of the second stage. So now we are injecting a value more than the backup value, so 34.5 milliamp, and the time of this state to be more than the expected trip time. So the expected trip time is 1 second, so we can inject for 2 seconds. And the trigger condition here is to be used with the trip contact changing from 0 to 1. And then you can define here the time assessment for the rotor earth fault warning, so and trip time for the relay 7UM622 Siemens relay. So at the end of the day, you will have all this information and assessment level based on the load tolerance, referring to the technical specification of the relay manual. Thank you, and stay tuned for the next video.